This is about ionic and covalent bonding. It is actually kind of easy. It does take a little bit of practice. First of all, we're going to do the ionic bonding. Now, ionic bonding is between a metal and a non-metal. So you should have a chart showing the metals and the non-metals, but the large part on the left is a metal, and I have referred to those metals as being big, fat, lazy losers. And then the non-metals are those gainers. So bonding in ionic compounds is something called loss and gain. We also have a little concept called electrostatic attraction. Because positive or losers have a positive charge, and nonmetals or negatives have a negative charge. I'll move this over a little bit so you can see that. And basically what you do is, let's say we do something in group 1, because all the ones in that column have the same properties, and I'm going to use Na. If you look at your chart, you have a positive 1. And then I'm going to use chlorine. Again, I could use any of those elements in the group, they do the same thing. So that would be your ionic bonding. If you notice, it has a 1-to-1 ratio. We're not going to go through how it is and how we're going to write the formulas for it. That's a little bit later. We know that Na has 1 valence electron, which would mean 1 dot. We know chlorine has 7 valence electrons. Make sure you know how to count valence electrons. And so it's going to look like this. If you have a positive and a negative, what they're going to be is attracted to each other. So basically what will happen is your Na will lose an electron, and the chlorine's going to gain an electron, and then they're going to bind together to form a compound, which is NaCl. Again, it's a 1-to-1 relationship, so you don't put any numbers down at the bottom. Let's go ahead and do another one. And by the way, that's called the octet rule. What does octet mean? 8. They just want to be a noble gas on both of them. So let's go ahead and do another one. And again, I'm just going to use the common ones. Let's say I have Al with a +3 charge. Again, you'd have to look at the chart. And then I have an N with a -3 charge. Again, it's a 1-to-1 relationship. So if we go like this, it's going to kind of look like this. Again, we're going to talk about loss and gain. So what's going to happen? Well, this one will lose 3, and this one on over here is going to gain 3. So that's what we're talking about as far as losers and gainers. That's when they get their charge. Again, we're operating on the octet rule. This had 5 valence electrons, it needs 8. This one will actually lose electrons to get to 8. Again, you don't really have to know that. It's the octet rule. Let's go with one that's not really the 1-to-1 relationship. Let's go with K and S. This one has a positive charge This one has a -2 charge. If we do the valence electrons, you know, 1, 2, 3, 4, 5, 6 for this one's in the first group. We have something that looks like this. Now here's a way to look at it. What we're trying to do is we're trying to balance out the charges. We've got to make it equal to a +2 to make this whole thing neutral. I only have a +1. So if I start moving them, which is actually one thing you can start doing, you'll have something that looks like this. Sulfur has 7. According to the octet rule, it wants to have 8. So what do you have to draw? Another K. With that's one valence electron. Now they're both happy. If I were to write a formula for it, it's going to be K2S. Because you need 2 Ks, which makes a +2, and then it'll equal the -2. And again, we're trying to get something that is neutral. That is neutral. So we're kind of just going into, almost into writing formulas. Let's go with this, -2 and a +3. Again, lose. Gain. These are unbalanced. But if you think of the least common multiple, how do I make it so it's neutral? I can make that equal to the +6. I can make that equal to a -6. It tells you how many ones you have to draw. So with this one, I know that in order to make it a +6, using that as a -6, I'm going to have to draw 3 of these guys. 2 of these guys. Apologize. On this one, in order to make it a -6, I'd have to add 3 of them. Again, I'm trying to make it neutral. Or this whole thing obeying something called the octet rule. So it kind of looks like this. This one needs to gain 2 on each one. There's my 2. This one has to gain 2. There's 1. There's 2. There's 1. There's 2. What would be my formula be? Al2S3. Again, we have to make it neutral. That is how ionic bonding works. Covalent's kind of a little bit different. We're going to use the dot diagrams that we're using right now, and we're going to show the covalent bonding. So we're done with ionic, which is my metal, non-metal. Now I have to do non-metal, non-metal. So it may be a little bit confusing to some, but basically I'm just using what we know before. And we have a gain-gain. Yeah, they both gain what they need in order to form an octet. We also call that co, which means it borrows valence electrons, valence, electrons. Or they co-own their valence electrons, which is kind of borrowing. So we have a gain-gain right now. They still want to obey the octet rule. Now this is just with dot diagrams and valence electrons. We have another concept we have to cover next. So let's go ahead and take a look at this, and we're going to go with CO2. The concept behind covalent bonding is the one that has the least amount of atoms will be your central atom. So it looks like this. If I look at my valence electrons and I count over, oxygen's going to be 6. You will have to position your electrons in order to show this type of balancing. And sometimes what will happen is they like drawing electrons as far away from each other. Either way works, but you'll see it both ways. So you'll notice oxygen has 6. You know that they have to borrow or co-own electrons. This is not loss and gain. I'm not dealing with a metal. Carbon has 4 valence electrons. So it kind of looks like this, because I have to expose those electrons to borrowing. Now what I have to do is I have to still adhere to the octet rule, which means 8. How do they get these 8? From borrowing electrons from other elements. So you will notice that by borrowing or co-owning, carbon and oxygen now have an 8. Let's say I do it with hydrogen. In some cases, we actually call this hydrogen bonding, something we need to go through. Let's say I have HF. Again, hydrogen bonding has a hydrogen. It's just 2 other elements that does. And again, I'm going to go through that. Hydrogen has 1 valence electron. It's in group 1. Fluorine has 7. So in order to make hydrogen happy, that's what's going to make hydrogen happy, because it wants 2. Just remember, it doesn't want 8. At the maximum, hydrogen can have 2 electrons, because it's in the first period. It wants to be helium. This one will gain, or co-own, the 1 electron from hydrogen. Again, we're following the octet rule for this one. This one doesn't really adhere to the octet rule because, again, it's not big enough to have that many electrons. And the formula for that would be HF. First one was CO2, or carbon dioxide. Again, the naming system you're going to notice is a little bit different. Let's go with H2O. This is another hydrogen bonding one. So you got this. And then you also have oxygen. And again, it's a little trickier to put your electrons here. Put them as far apart as possible. Again, hydrogen wants only 2 electrons, so that fulfills what it wants. This fulfills what it wants. And there's the 8 that oxygen wants to fulfill the octet rule. We know that water is H2O. Now let's go ahead and do one last one. Let's go SiCl4. Again, covalent compound, Si and Cl are both nonmetals. They want to gain. I have my chlorines here because, again, lower amount goes in the middle. It just kind of makes sense. Kind of look kind of weird if you put 4 chlorines in the middle because it just wouldn't work. And then we go I have to be a little bit creative on the drawing here. Actually, not too creative. Chlorine has 7 valence electrons. Chlorine has 7 valence electrons. Chlorine has 7 valence electrons. And this chlorine has 7 valence electrons. If I look at Si or silicon, it has 4. Let's put my 4 here. Now, since they're not hydrogen, they all want to have 8. 8 octet, 8 octet, 8 octet, 8 octet. And then also silicon needs that 8 too. Kind of looks a little weird, but I just have to draw a circle to get my 8 electrons. Now Si actually has to follow the octet rule. So that's how you kind of deal with this. The next section is going to be something called Vesper, and I'm going to show you how to draw those. This one you'll see, Vesper is just a little bit different.